there. One branch of maths which is really applicable to real life is that of geometry. And with geometry, one part which is really important is this part to do with angles. So in this video I'm going to introduce you to angles. So you can see in this beautiful picture of Whananaki South, which is a little bit northeast of Whangarei in New Zealand, you can see that we can use angles in any sort of practical application. For example, if you've got a house, you can find types of angles like acute angles. If there happened to be a sailing boat on this estuary, you would see that there are angles in the sails. And then some terms that I'd like to introduce you to are terms like horizontal, vertical, complementary and supplementary angles, etc. So we're going to have a look at those terms and the types of angles that you'll come across in this video. So what is an angle? An angle really is a measure of turn. So if you have some revolving doors, the actual door revolves around a pivotal point, which is this point here. So that's where we get the word revolution. So these glass doors could go through one full revolution, which would be 360 degrees. So if this door would revolve right around, so if it's turning clockwise, for example, and it turns through 360 degrees, we say that is one revolution. If it turns round, say half a turn, so half turn, we know that that is 180 degrees. So a half turn is the same as 180 degrees. If you're a person who works in, say, the food industry, and you have these large tanks with big rotating blades, for example this one here, see my crude drawing of an ice cream tuner, you've got these blades here, and say we have 3 blades, you could see that this turn would be a third turn. Now if we know that one revolution, if we know that one revolution is equal to 360 degrees, then a third turn would be 1/3 of that. So a third turn would be 120 degrees. If we're looking at a clock and we're looking at the movement of the small hand from 3 o'clock to 9 o'clock, 6 hours later, that small hand has moved through a half turn. So a half turn would be, we know, 180 degrees. So if I'm looking at, say, from 3 o'clock to 6 o'clock, of course that would be a quarter turn. Now a quarter turn is equal to 90 degrees. So angles are a measure of turn. Okay, let's move on and have a look at a few definitions. First of all, let's look at what does the word vertice mean. Vertice is plural for vertex, which is basically a point. So that point there, that point there is point D, and that is called a vertex. This point here, which is not named, that is also a vertex. So if you have more than one vertex, you have vertices. Now this word here, arms, so if we look at this diagram here, these things here are called arms. And the angle that we're interested in would be that angle there. So that angle there is between 2 arms. Now naming angles, we generally name angles with 3 letters. So if you look at this truss, which is a part of the roof of a house, if we were to name this angle is at the vertex A. but we can see that this angle is encapsulated between two arms. So this arm and this arm here. So when we name our angle, we want to name it with 3 letters. So I'm going to start at B. If I start at B, travel to A, and then travel to E, I have encapsulated this angle here. And so we use this symbol. This symbol is the symbol for angle. So this angle here, we name it as angle BAE. If I was looking at this angle here, that angle there would be named angle B. So start at B, go to C, and then travel to E. So it would be angle BCE. Could you ever go at naming this angle and this angle here? Just pause the video now. How did you go? These are the answers to those 2 angles there. Notice that the actual angle is always at the middle letter, at the vertex of the middle letter. Okay, so let's move on. Here are a couple of terms that you should learn. So the word horizontal, if you think about a horizon, the word horizontal actually comes from the root word horizon. So you look out your window and you see this horizon here with the sun coming up. So the word horizontal comes from horizon. So it's basically a line that looks like this. That's a horizontal line. As opposed to vertical, so I've got a goalpost here. So that post is vertical, as is this joker here who is about to have a go at shooting the ball into the hoop. Unfortunately, he misses, so now he is horizontal crying. So here is horizontal and here is vertical. So you should know the difference between those 2 terms. Okay, complementary and supplementary angles. These are just ways of naming different types of angles. So complementary angles add to 90 degrees. So if you've got angles and you add them together and they come to 90 degrees, then those angles will be complementary angles. So if we look at this angle here, this is a 90 degree angle. So we put that sign in there to indicate a right angle or 90 degree angle. So this angle here must be 68 plus what will give me 90 degrees. So that would be 22 degrees there. So if I was to name that angle, be angle BAC, and that's equal to 22 degrees. So complementary, add to 90 degrees. Supplementary angles are angles that add to 180 degrees. So I've got a straight line here. So JL is a straight line. And I know this angle here, it's 122. So what would this angle here be? So that angle here must add to 122 to give 180. So 122 plus 58 degrees would give me 180 degrees. So this angle is 58. So supplementary angles add to 180. Let's have a look at the types of angles now. You may have already come across these types of angles. So we have acute angles and acute angles. Acute angles are angles that are less than 90. So if I look at this angle here, here is an angle that is less than 90 degrees. So 90 degrees is a right angle. So here's a right angle here. Here's another right angle. So both of those angles are 90 degrees. So you can see that these two angles here are less than 90 degrees. Okay, so they are called acute angles. Acute. The next type of angles are angles that are between 90 and 180 degrees. So these angles are called obtuse angles. So of course, an angle that is 180 degrees would be a straight line. Okay, so that is 180 degrees, it's a straight line. So we want to identify angles that are less than 180 but greater than 90. So probably this angle here, okay, that angle there would be obtuse, as well as this angle here would also be obtuse. So you can see that those two angles are greater than 90 but less than 180. And the last type of angle is called a reflex angle, and that angle, those types of angles are between 180 and 360. So let's have a look at some reflex angles. So if I had, say, something like this angle here would be a reflex angle. You can see that it is greater than 180 degrees, but it's less than 360 degrees. Okay, estimating angles is really important. If we look at the side of this roof here, so for this house, that angle there, you'd need to try and estimate it. Of course, you can definitely see it's an acute angle. Acute angles are less than 90. So 90 degrees would be something like this. So it's about half, maybe a little bit less than half of 90. So it might be around, I don't know, maybe 40 degrees. So that little symbol there means approximately. So 40 degrees, about. Okay, here is a windmill. And if we were looking at this angle here, so if I were to draw a couple of arms, you can see that it is greater than 90 degrees, but not greater than 180. So it's an obtuse angle, so somewhere between 90 and 180. So it's always good, you can always draw a 90 degree angle in and then estimate it from there. So it's 90 plus maybe 45 approximately. So we're estimating this. So about maybe 135 degrees approximately. Okay, here are a couple more angles we could estimate. We could estimate this angle here. We've got a ladder leaning against a wall. So that angle there is less than 90. If I were to draw another arm there, okay, and looking at this angle here, I think it looks like it's about half. It might be a little bit more than half. So it looks like about 50 degrees. So these angles here, let's look at this one. That's not quite 180 degrees. 180 degrees would look like this. Okay, straight line across there. So it's a little bit less than 180. If I estimated that angle there, that might be maybe 20 degrees. So this obtuse angle looks like it's about 160 approximately. And then this last angle here, it is definitely greater than 180. So if I were to draw a straight line through there, you can see that this angle is greater than 180, but it's not quite 270. Now remember, 270 degrees is actually equal to a 3/4 turn. Okay, so 3/4 of 360 is 270. So that's a 3/4 turn, which means that that would be 90 degrees. So if I'm looking at this angle here, it's a bit more than 180. That looks like it's about 50. So 180 plus 50 is 230. So that might be approximately 230 degrees. Okay, so that's estimating angles.